Good morning, everyone. Today we'll discuss about compaction. What is meant by compaction? Compaction is a process of densifying the soil sample. When it is in loose state, it is going to become a dense state. So this is also a process of simple ground improvement technique where the soil samples have been densified through external application of force. So you can witness here, soil samples have been in a loose state. So we are going to apply an external force due to this. So as an external force has been acting on top of a soil mass, the soil gaps which have been there will be started to eliminate, and they are going to relocate the new position, and finally denser particles will be looking like this. So this set off process by external application of loading is known as compaction, so which enhances the density of the soil sample, and finally once the density has been enhanced, we can get back more strength and we can attain more stability in the soil surface. So this one ground improvement technique which we generally will call. So to obtain compaction in a laboratory, we are having two different aspects. One is a laboratory compaction method by standard Proctor test, another one is by modified Proctor test. So this is a mold of soil sample where we can compact the soil. So mold with a collar has been fitted, and we can use a soil sample is been placed. Let us assume 3 kg soil sample has been taken, and we are applied 6% of water to the soil sample, and we mixed thoroughly the soil and water together so that a uniform color has been arrived. Moisture has been spreaded evenly into the soil surface. Once this has been arrived and once this has been confirmed, we can transfer the soil sample into the mold by 3 layers. We can apply. So first layer will be placed, and we can give 25 number of blows if it is standard Proctor test. If it is a modified Proctor test, we will apply 25 blows with 5 layers. Here 3 layers only, but a rammer difference will be there. The weight of rammer we are using in the standard Proctor test is 2.7 kg, whereas in case of modified Proctor test, the value of rammer, weight of rammer is 4.9 kgs, and the height of fall will be here in 310 centimeter or 310 millimeter, that is 31 centimeter or 30 centimeters rough approximately. So here height of fall will be 45 centimeter or 450 mm. So here for 3 layers we are going to compact the soil surface. Here 5 layers we are going to compact the soil surface. So this is the only major difference where we adopt standard Proctor test is for natural roads or construction or village road construction or house constructions. Standard Proctor test is being used. If it is a national highway or expressway or very important structure like a military grade roads or military army services roads, so there we can adopt modified Proctor test. Or railway lines or runways, so their modified Proctor test is being used because they require very high intensity of loads which are going to come through. So there if you adopt a standard Proctor test, it will be a failure. So to overcome that, we have introduced a modified Proctor test to enhance the strength. So definitely, again, let me get back to a simple aspect. What is meant by compaction is a process of ground improvement to external application of force. So we are not directly compacting the soil. We are adding water to the soil sample, and we are going to make that effort of external force, and finally we are going to make this a dense deposit like this. So if you compact the soil sample by layers as we have discussed in the standard test or modified Proctor test, we'll finally draw a graph between dry density versus moisture content. So like this a curve will be obtained. So usually at this particular circle we can enhance that, we can ensure that soil particles have been densely packed and they are having a long very good strength and they are having a good stiffness. At this particular extent we are having low permeability. So the peak value we call it as a maximum dry density, and corresponding value we call it as a optimum moisture content. So these are the two characteristics of compaction test. One is optimum moisture content, second one is maximum dry density. And again here we can see through in a compaction curve, three phase diagrams it can be measured. So first a curve is being produced like this. So you can see a curve of a green color which indicating a compaction curve. So here the soil sample is been there in a yellow color, whereas in the blue color we indicating it as water, and the top one which is considered as air. So lowest void ratio will be there in case of here, and the high, we can see dry density will be optimum corresponding to this. As we are adding water in initially, here water is been less, here water content is been more, density has been decreased, but here sufficient amount of water is been there means density has been more. But whereas if you increase beyond that, water content has been increased, automatically dispersion or the contact between one particle to other particle lose due to intrusion of water more, so automatically strength has been lost. So another thing we can witness here is zero air void line or zero air void curve. So here after plotting a curve, so it has been represented, this has been not at 100% saturation. So if the soil is been 100% saturated, what will be the density? It will be looking like this. So like this, if you touch, this is the first point, this will be the highest theoretical dry density value. For that we require G into gamma W divided by 1 plus WG by S is a standard equation, where G is WG by S is 100% saturation, where that value will be 1, and all compaction points will be going to join like this. So this is one aspect we can learn through here in zero air void line. And second one, you can see through as I have done standard compaction test and modified compaction test. So density has been increased and water content has decreased, and here in the standard Proctor test, moisture content has been more when compared with first equation or first curve. So lower the optimum moisture content will be there in case of second one, that is E2 will be larger than E1. So being higher intensity of load has been given to this. So here lesser intensity of load has been given, less density has arrived. Here higher intensity of load has been given, higher density has been arrived. So with this we'll stop today our discussion of how compaction has been processed. Okay, thank you. See, continue in the next session.